Hello, and welcome to this presentation, Getting Started with the ZNB3000 Segmented Sweeps. In this presentation, we'll show how to configure and use the segmented sweep function of a Rohde Schwarz ZNB3000 series vector network analyzer. This presentation assumes a very basic understanding of segmented sweeps, as well as both how and why segmented sweeps are used in VNA measurements. If you're unfamiliar with this topic, or if you'd like a brief review, you might want to watch the presentation Understanding VNA's Segmented Sweeps before beginning this presentation. As the name implies, a segmented sweep divides the sweep range into multiple subranges or segments. Segments are smaller frequency ranges within the total frequency range. Each segment has its own measurement parameters, meaning that the start and stop frequency, number and spacing of points, bandwidth, power, etc., can be set differently for each segment. Using segments can increase measurement speed, provide greater accuracy or resolution, and can be used to optimize dynamic range. As shown in this example, more closely spaced points can be used to provide greater resolution for the more interesting parts of a trace, such as the passband of a filter, and fewer points can be configured for less interesting regions in order to reduce overall measurement time. To configure segmented sweeps on the ZNB3000, press the sweep hard key and then choose Segmented under Sweep Type. Note that before this option is available, the segments must be defined under Define Segments. We'll go over this in detail on the next few slides. As with most other VNA measurements, an appropriate calibration should be performed using the segmented sweep settings. An existing non-segmented calibration covering the same frequency range could also be used, but in this case the points will be interpolated, and the calibration label will change to CalInt. Let's now look at how segments are defined. By default, there are 4 columns in the Define Segments table. On-off enables or disables a particular segment, and start frequency and stop frequency are the lower and upper limits for the given segment. The distance between sweep points is set using frequency step size, but this can also be defined by points and the start and stop frequencies. Note that for a given frequency range, changing the frequency step size will change the number of points, and vice versa. Additional per-segment settings are configured using active segment settings. The most common additional settings are Name, which allows each segment to have a user-friendly name, Measurement Bandwidth, which is the IF bandwidth, Selectivity, which defines the selectivity of the IF filter, and Power, which is the source power for each segment. There are also some additional, less commonly used parameters, so please refer to the ZNB3000 documentation to learn more about these functions. After enabling additional columns, these will appear in the segment table and can be directly viewed and edited by the user. Here, we've given each segment a meaningful name and have chosen different bandwidths for the different segments in the sweep. There are 2 other useful settings when defining segments. The first is Import-Export, which allows segment tables to be saved as or loaded from an ASCII file. The second is Show Point List, which displays a list of each measurement point in the sweep, along with its segment name and bandwidth. Let's look at an example of using a segmented sweep. Here we want to measure the passband of a filter that's approximately 30 MHz wide. We'd like to measure this using a 100 kHz step size and an IF bandwidth of 10 kHz. If we use a linear sweep, as shown here, this same step size and IF bandwidth will be used for every point in the trace, even those outside of the passband, and the total measurement time for each sweep will be approximately 543 milliseconds. We could, however, make this same measurement using a segmented sweep by creating a sweep with 3 segments, one for the passband, and one each for the lower and upper stop bands. In this example, we're primarily concerned with the passband, so we increase the step size and IF bandwidth outside of the passband to 1.5 MHz and 100 kHz, respectively. As a result, the overall measurement time drops to only 113 milliseconds, which is a roughly 5-fold improvement in test time, but which does not cause any loss of resolution in our measurement of the passband. Let's end with a brief summary. Vector network analyzers generally make measurements at discrete points consecutively over a user-defined frequency range. On the ZNB3000, this range can be divided into segments, each with its own start and stop frequencies and number of points or step size. In addition, the IF bandwidth, power, etc. can also be set individually for each segment. There are many applications for segmented sweeps, since these can provide significant advantages in terms of speed, accuracy, and/or dynamic range. Configuring segmented sweeps on the ZNB3000 is very easy. Simply enter the segment parameters in table form via the graphical user interface, or import the segments and their settings from a file. This concludes our presentation, getting started with the ZNB3000 segmented sweeps. If you'd like to learn more about segmented sweeps, other VNA-related topics, or vector network analyzers from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.